Next, we're going to move to actually plumbing the gases and move into the startup operation. But since the oven enclosure, we call this sample processing module, is open, we'd like to point out that as with any gas chromatograph, it's very important to make sure that the system is leak-free. And once the instrument is put together and you have gases fully plumbed, it's a good idea. It's quite handy with the hydrogen as carrier to use a small hydrogen leak detector. They're basically a little thermal conductivity device, and of course hydrogen has a much different thermal conductivity than air. And so what one would do for leak checking is to start at the bottom. Of course the carrier gas must be turned on so you can actually have pressures. But starting at the bottom, not at the top. If you start at the top and move down, you won't know where the leak actually is if it happened to be on the bottom. So start at the bottom, check with the leak detector here, 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 and around these fittings at the sample inlet. And of course, when you get ready to plumb the gases, the leak checking must go on at the utility panel also. This is a normal syringe through a septum style injection port. It is a rather normal inlet with a glass liner that can be packed or not packed depending on the application requirements. It is a bayonet mount style so that it's pretty easy to change the septum. Simply loosen these Allen wrench screws with some thermal gloves. If it's still hot, twist it, lift it off, and easily replace the septum. What you see here is the split vent trap. It is a consumable, however, it's got enormous capacity. It's packed with a little bit of charcoal or carboxylate style adsorbent, and really all the function that this has is to keep the hydrocarbons that result from the split process on the inlet from reaching the electronic pressure controller that does in fact control flows, and it's critical at that point in the operation. And you see possibly 4 mounting screws. This is where we would mount either a rotary or a diaphragm plunger style automated sample valve. Again, it's controlled by using this auxiliary port or in combination with the auxiliary port on the side to fully automate the sample introduction. And again, if you're using a syringe style auto injector, it connects and is programmed through the personal computer. And of course on the front there's a display, and we'll get into that in just a moment. Okay, so the handy thing about CALIDUS is it actually has a handle, and you can move it around a little bit, make it a little bit more convenient. Remember, we hooked up a little Y or T of the air lines, and it's pretty hard to get them confused because use a typical fitting for chromatography. I guess this would be called a female fitting, and it goes on to the male fitting that's labeled air right on the top or the side of the GC. And again, we don't need to go crazy with tightening. Over tightening is as bad as under tightening. Just snug it up and bring it home just a little bit. We're going to leak check as well. Don't ever forget we have to leak check. So now the air line is hooked up. Recall we also had a structure on a T for 2 GCs, and this arrangement enables us to use hydrogen for both the carrier gas and the fuel for the FID. And what we're going to do is just put them in either one of those ports, since it's both hydrogen, and it goes together pretty quickly. So now we have both carrier gas and fuel for the flame ionization detector, and what we're going to do is snug these fittings down as well. And it doesn't take much. They seal pretty well. When they get tight, just give it a little bit more of a tug. Not too much. Again, over tightening is nearly as bad as under tightening. You can always find a leak. So just bring it to the point where it feels tight in your fingers. And we're just gonna, it's almost tight in my fingers. And one more little tug on it, and we're going to call it good. So now what you see is the hydrogen feeding, the fuel for the FID, and the carrier gas supply, and the Teflon tubing that's white here is supplying the air. And on the back is a 24-volt DC power supply. It goes through this cable. There's a little locking ring on the cable itself, so once it's seated and in place, you twist the locking ring and it holds the cable in place on the side of the utility panel. And you can see there's a little key right here. It's kind of hard to see because it's black. And basically what happens here is you can't get it wrong. You push it down and into place, and you twist the locking ring until it clicks, and then it's in place.